Hello there, and welcome to the second episode of Quick and Dirty TwitchLib. In this session, we'll be creating a console app integrated with TwitchLib's EventSub. For starters, there's a few things I won't be covering, and these are all listed above. For the most part, we're going to be focused on directly implementing the application, so a lot of these fundamentals and other workflows are yours to learn in your own explorations. As far as what I will be covering, we'll be recapping the registration of the application on Twitch and how we get our first tokens and all of that stuff through the CLI. We'll get into API usage, including the auth refresh process and building an authentication service as a little bonus. And then we'll be getting into event subscriptions with Websockets and listening to messages and redeems and doing some sort of a response to those things. All right, so why don't we go ahead and get started? So the first thing we're going to want to do is go to dev.twitch.tv and we'll wind up on their dashboard. Make sure you're signed into your main account or whatever account you want to be the owner of all of your applications. Once you've clicked on create a new application, just go ahead and fill out all the info as you can see in the fields. Make sure that you select a category for your application. Specifically, in our case, we're selecting chatbot because we're making chatbots here today. Then you're going to want to go ahead and enter an OAuth redirect URL. Make sure that that is set to localhost 3000. You shouldn't have to do any port forwarding or anything like this. It should just work out of the box with the Twitch command line interface. Go ahead and click on create, and you will find yourself at the developer applications menu. Go ahead and select manage on your application that you've just created now. And once you are in that page, you'll notice there's a client ID at the bottom. Go ahead and click on new secret in the secret category and click on OK to confirm you want to generate a new secret. Once you've done that, you'll have all the information that you need to hook into the command line interface. So the Twitch CLI is easily configured with Twitch configure. Once you enter that, you'll enter your client ID and secret. If you have any problems entering those, sometimes the copy pasting doesn't work quite correctly in the console in my experience. So try using smaller chunks, just cut the overall strings in half and you should be able to copy paste them in after a couple tries at worst. Maybe you'll get lucky and it'll work first try for you. Once you've done that, enter in Twitch token-u-s with the provided scopes list that we're requesting. You should open up a browser page that will show you the authentications that you are approving for your application's credentials. And then once you've done that, you'll have your final user access token, refresh token, expiration time, and the list of scopes verifying that you got what you requested. As a brief explanation of the concept of scopes, say we're trying to send a message through the API. We may have our token and our bot may be valid and allowed to actually use the API, but we still require permission to use a specific category of functions. There are 3 scopes that are listed. One controls your actual ability to write a message in chat in the first place, and the other 2 are kind of user designators. So in this case, channel bot is basically always going to be needed so that we have permission on our application to send a message in the channel. But we also need user bot in the case that we are running our bot as a completely separate Twitch account. For every action that you will take on the API, you will likely have to go through the reference and find the function that you're trying to call and make sure that you have all of the correct scopes for everything, because each individual action will likely have a different scope required. So now the fun part starts. Let's go ahead and create a console application. We're going to go ahead and name it Twitch EventSub App Tutorial, or whatever you would like to name yours, of course. Don't let me stop you from naming your project freely. We're going to go ahead and make this in .NET 10 and follow any configuration standards you would like, but otherwise you can copy what I'm doing. We'll go ahead and hit create. We're going to be building things using dependency injection and application hosting. So we're going to want to go ahead and open up the Nuget package manager, and we're going to want to type in extensions hosting. And Microsoft Extensions Hosting should be the first one that comes up, but if it's not, just look for Microsoft Extensions Hosting right here and get that installed. And then we are also going to want to grab Extensions Dependency Injection. And again, you should look for Microsoft Extensions Dependency Injection. And we'll go ahead and get that installed. The first thing we're going to want to do is create our actual application builder. So we should be able to type in var builder equals host, and we should see Microsoft Extensions Hosting right there. And then we can type in host create application builder, and that will create our actual application builder. This will be where we actually leverage dependency injection. So now we can use builder services, which is our dependency injection service collection. So all of the systems that you will register to be used have to be registered to this services collection. And we'll type in add logging, because one of the first things we're going to want to do is make sure that we can log information and see that this actually is working. Then we can build, and this will create a finalized hostable environment. We can say build services, because now we're accessing the constructed application service container, and we can type in get required service iLogger, which is the interface for a logger in this case, program being the target class that we wish to log for. And as a test, we can try to log information, beep, just to make sure that our application is working. And then we can type in build.run at the end. And if we go ahead and save this and hit run, it will open up a console in just a moment. And in that console, it will launch the application. And you can see right here, we got our info, beep, and then we got all this extra stuff. So this is the actual environment hosting setup. And this is going to provide more useful information as you go. If you end up hosting an API or anything like that, it will display all sorts of information about your hosting environment in here. But either way, step one is complete. We've now actually launched the application and we've got a service injection container. So now we're going to need to install a couple more Nuget packages, this time for some of Twitch's functionalities through TwitchLib. So we're going to type in TwitchLib.api because we need the TwitchLib API itself. Just download whatever version is the most recent. As far as I can see, it was just updated in October of this year in 2025. So as long as it's the most recent version, you're most likely to have all of the updated endpoints that Twitch has available. Then once we have the TwitchLib API, we also need EventSub, and we're looking specifically for EventSub Core and EventSub WebSocket. And in my case, I've already gone and installed these, but you can find them right here: TwitchLib, EventSub Core, and EventSub WebSockets. And we need specifically these two. We're not using the webhooks or anything else, just WebSockets and Core. So now that we've actually installed EventSub, we need to make sure that we add it to our service container, because TwitchLib conveniently provides an implementation that is built to work with dependency injection. So we'll go ahead and type in builder services, add TwitchLib EventSub WebSockets, and it should show up at some point in your hinting. And that will make sure that all of the required classes for EventSub are provided automatically. For the sake of this tutorial, I'm going to show you a method of just reading and writing from a JSON file your authentication information. I wouldn't recommend doing this for a production application, but in general, if you're not hosting this to the internet and it's just for you, this is a perfectly safe way to do this for now. So I'm going to type in auth in a folder in here, and we are going to create first a resources file. And the resources file is going to contain our client ID and our secret so that we can keep those safe from everything else. So we're going to make a resources file. And in here, I will type in my auth information, all that stuff, but I'm not going to do that in front of you here. But I will show you the essence of it is you'll type in client secret. It will be a type of string, and then you would type in your secret here. And then we would do the same exact thing for the client ID. And it would also be a string, and then it would be your client ID there. So in your own time, go ahead and copy paste in the client ID and secret that you have in your note document over into this here. And then once you've done that, we can create another little piece of this puzzle here. We'll create a data class that will contain our authentication information for serializing into JSON. So for that, we're going to do a C# file. We're just going to create a class. We're going to call it Auth Info. And in this class, which we'll make sure is public, we are going to go ahead and have a public string refresh token. We're going to have a public string auth token. And we're going to have a public date, time, death, time, UTC. And the reason that I'm labeling it as UTC is because I don't intend to convert this into my own local time. This is going to stick to what it is, and that's just how it's going to work. And then we can take this auth information and use it in JSON serialization. So we'll make sure that this is all set up as public, and these are all properties so that the JSON parsing will handle it nicely. So now we've got our auth information built, and we've got our resources file safely stored away so that we can, oh, I should probably rename this. I should actually have this named appropriately. So we'll call this secrets. And then inside of our secrets resources file and our auth info classes, we'll be able to handle all of our auth information. So we'll go ahead and create an auth manager service. And inside of this auth manager service, we're going to need a few things. We need an API instance. We need an address for an auth file to be saved and loaded from. And we need a reference to an active auth instance. So what we can do is have a private iLogger for our auth service. And we'll also have a private reference to the Twitch API. And then for both of these, we can actually include them directly inside of our constructor here. And by including them in the constructor, we'll be able to signal to the dependency injection container that these should be summoned from the container. And so over on the program side, we'll add builder services, add singleton, Twitch API. And then we will also do an add singleton for our auth manager service. So now that we have that as a part of our dependency injection container, we can change our starting functionality a little tiny bit. Instead of getting required service iLogger program, we can actually change this over to our auth manager service just to test things. And then we'll move our test function over there. So we'll just say auth test function. And we will wire up a test function over here just to demonstrate how the logging works. Public void test function. And we will log a beep from over here instead, just to verify that all of this works. So now we've registered our subservice, our little auth manager service. It currently doesn't do anything, but it does have an API reference and it does have a logger. We can hit start on this. You can see that we still get our beep, except now we're getting it from the auth manager service. What's really cool about the logger is that it'll always tell you exactly which service and what namespace and all of that it's coming from, which is really, really helpful. We've added our API instance, and we still need to add a reference for the active auth instance and an address for the file to be saved and loaded from. I'm just going to put a private string load location, and I'm going to grab that location from my machine in just a second. So for now, I'll leave this blank, and later on this will be filled in. Just know that you need to pick a location on your computer where you would like your authentication file to be saved. So then we're also going to want to go ahead and add a reference for our auth information that we created earlier. So we'll also have a private auth info auth. And then that should be all we need. Oh, and actually we should make these follow naming patterns. Naming patterns are nice. We can go ahead and configure our API a little bit. Settings. So we can add the secret and the client ID from our resources file that we've already created earlier. So hopefully you've populated that with the information that you need. So we'll do secret equals secrets.secret and API settings client ID equals secrets client ID. So we can go ahead and do something cool now, and we can set up the auth manager service to automatically start whenever our application starts by changing it to an iHosted service. And you don't need to know too much about this to use it, but essentially all it's doing is registering this particular component as something that will have a start and stop method that get called when the entire application starts and stops. So we'll add a singleton auth manager service, and we will also add a hosted service on the same type. And then we can leverage the start and stop async methods to do all of our refreshing of our token and any sort of initial checks that we want to do inside of the auth service. So the first thing we're going to want to do here is try to access our file. So on start async, we're going to want to try to load the file from the location, parse the auth file, and check the API if the token is valid. If the token is valid, we're good. And if not, we want to refresh the token. And this whole process should take place here. So that way the entire application will kind of hold on and wait for this to happen, but it'll still be within that async thread. So to start with it, we want to try and load the file from the location. So we're going to trust that we are capable of creating a folder and creating a text document inside of that folder. So var loaded text equals file read all text, and we'll do it from our load location. And that would get us our loaded text. And then we can say var parsed equals, and we're going to use system text serialization, JSON. Serializer, serializer, deserialize, auth info from our loaded text. And then we're going to say if parsed is null, parsed equals, well, we're actually going to set the auth directly. Auth equals new. And for now, that's how I want to do this because I specifically want to create the file and then try to save it. So we'll do await save. And we'll go ahead and create just a quick async method that will handle that. Private async task save. And for now, we won't worry about it too much. So we'll go in, we'll try to pull the information from a text document, and we'll try to parse it. If it's null, we'll assume we need to create new auth information and save. And then we're also going to want to try to validate the token or get our tokens, but we'll have to enter those manually the first time. So this will be where we'll return out. And if anything, we could even throw an exception. So we could do logger log error. Hey there, I need to add the auth information to my new file. And that way you can just go to your directory and add the information to it. So I've already gone ahead and selected my file location of just being a folder inside of my C drive. For your case, you can put this wherever you want. I really can't clarify enough. You can put this wherever you want. Just don't upload it to your GitHub repo or anything like that. Keep your secrets sources file out of your repo as well. So then I've created this authentication JSON file. It's completely empty right now, which is great. And then we're going to go ahead and set this up so that when we actually try to save, it saves the file. And one other thing that we need to check here is we need to do a try catch. So this actually needs to be auth info parsed equals null. And we want to surround this in a try catch. So we can hit Control K and then S if you're on Visual Studio 2026 or 2022. Both of them have the same hotkey for this. And we'll type in try. And then we are putting in just a normal exception type, and we'll call it exception E. And then we will reference our logger, log error, failed to parse JSON, and then we'll include the error alongside of it. And then regardless of whether this succeeds or fails, we're still going to continue from this point because we're already checking for whether or not our parsed information is null. So at this moment here, we would technically create new auth information and save. So we want to do the same exact thing here, where instead of reading the text, we want to write the text. So we're going to do file write all text, and then we're going to do system text JSON serializer serialize auth. And we're going to make sure that we write all of that text to our load location. And now that will make sure that we write all of this information to disk. So for now, we can put return task completed task on the stop async because there's nothing really we want to mess with as far as this goes. There shouldn't be any shutdown protocols right now. We should be totally fine. So now we're checking if our loaded document has parsable data. And if it does parse, we load it. That's great. And if it doesn't parse, which is what we expect to have happen right now, we will go ahead and create new authentication information here. So we'll go ahead and hit play, or hit start or whatever. And we'll get a big old error that says it doesn't contain any JSON tokens, but then we'll continue through. You can see that we actually have some blank information here. So what we're going to want to do is populate this JSON file with the tokens that we generated earlier. So now we should have a completely valid authentication token plugged into our JSON file here, and we just want to check and make sure that it's actually valid. We will take the information that we have in auth and plug it into our API first. So we'll go API settings, access token, and we will use auth access, or auth token in my case is what I've named it. And that will make sure that our API actually has access to that auth token. And then we will do our first API request. So we'll say var auth result equals API auth. And then I believe it is refresh, or no, it's validate access token, because we don't want to refresh yet. We just want to validate it. And then we can do logger log information auth result is in total seconds of lifetime remaining lifetime. And thanks to the logging system, the way it plugs in variables is we just add them as a parameter object afterwards. So we can just say auth result, and we can say result. Oh, that's right. We need to await this. Got to make sure to await it. Await. And then we can say auth result dot expires in, and expires in is the total seconds until the value or the auth token expires and you have to refresh it. So now if we hit start, it should accept our token. Ooh, object reference not set to an instance of an object. Auth manager service start async line 34. So if we look at line 34, well, hey, hold on a second. That's our auth. Why is that? Oh, right, because we didn't set it. Auth equals parsed. And now it should work. And there we go. And we can see right here, we do a validate. We get a response. Yep, lifetime remaining right there, 6,359 seconds remaining. So that's excellent. And also, I should note, if you are working on these things on stream, it would show all of your client information, and you don't exactly want to do that in the middle of a stream or a broadcast of any sort. So be sure to protect that information accordingly. We want to make some assumptions in the case that the token is expired. So what we can do is we can say if auth result expires in equals 0, then we want to call for a refresh. So we can do await refresh token. And we'll do this as its own separate method because we'll probably take this whole thing. If anything, we will take this whole thing, we'll extract it as a method, and we'll call it validate token. And then inside of the refresh token method, which we'll also generate, all we're going to do is call out to the API, refresh the token, and store the result. So var result equals await API auth refresh auth token async. And this is where we need our refresh token. So once again, we're going to have to go into our auth, and we're going to use our refresh token. And then we have to go into secrets, and we have to get our client secret, which I'm going to have to edit out there as well. And once we have those two things, we can get our result. So then we can say logger log information result received auth token should have refreshed. And in the case that it fails, in my case here, I'm going to let it fail. We can throw in some try catch and stuff like that. But in general, if your auth process is failing, it's probably a good thing that your application just stops and you fix that ahead of time. So what's really cool about this setup is because of the nature of dependency injection, by having the auth manager service managing our token and doing these auth requests first thing when the application first boots up, we can basically guarantee that by any time any subservice gets our Twitch API singleton, it will already be validated by the auth workflow. So it makes things a lot simpler for managing references of the auth in the first place. But before we move away from this, we've gone through the process of refreshing the token, but we're not actually storing it or saving it to the drive. So we want to make sure we do both of those things. So to start off with, we'll immediately update our auth instance. Auth token equals result access token. Auth refresh token equals the result refresh token. Auth death time UTC equals date time UTC now. Add seconds result expires in. And then this will allow us to log the death time too. So we can say death time is death time. And we can pull that to local for displaying in the console. So then we can say auth death time UTC to local time. And it should toString it in a way that's readable. So we should just be able to leave it like that. And then we want to make sure that we actually update the API. So we'll say API settings access token equals auth access or auth token. So that way we actually make sure we can fully refresh this. And then we will do await save. And alongside that, we also want to go ahead and change our validation step to make sure that we are doing a try catch here as well. So we will do exactly that with a little try snippet. And we'll say logger, log error. Assumingly this is from expired token, auth validation failed, will reset token. And then we'll go ahead and remove the throw and we will do await refresh token. So that way, if we fail anywhere in this process, we'll try one more time. And assumingly we fail at this stage of the process, it won't really matter and we'll have to figure out what's going on there. There is a small chance that if you wait too long, like if you don't use your application for quite a while and you go to launch it for the first time in a decent bit, your refresh token may also be expired, in which case it won't run at all. It won't work and you'll have to go into the CLI and do a reset on that. But that's a small issue and you really won't be facing that if you're running your bot even like once every few days or something to that effect. However, there's still one more thing I want to show you because we're managing our auth token when we first launch our application, but we're not continuing to check its status throughout the lifetime of the application. If we were to have our token expire in the middle of a session, we would have no way to handle this presently. So what we want to do is we want to use a timed system. So there's actually a periodic timer that we can use, and we can call this check timer. And the periodic timer takes in a time span. So we can just say from minutes, we'll say every half an hour. So we will say that we're creating a periodic timer where every half an hour we will go and do a quick API check and see if our token is still valid. And we'll only do this if the expiration time is less than the 30-minute increments. That way we're not sending needless API requests. There's no reason that your token will suddenly get expired unless you are doing something naughty and Twitch decides to shut off your token, in which case you probably don't want to just be refreshing your token every single time. You'll want to double check and make sure that you are expecting things to shut off. So either way, we'll go through and we will create a private async task auth check. And this is going to rely on a cancellation token. So we'll use a cancellation token source, cancellation equals new. And then in cancellation, we'll say while cancellation requested is false. So that way, even though it's running asynchronously and potentially being managed in a different thread, we can still access it and tell it to stop. And that way we can leverage that inside of our stop async. So inside of stop async now, we can convert this a teeny tiny bit to say cancellation, or what is it called? Yeah, underscore cancellation, cancel async. And we can call for this to cancel. So now when our application stops, we'll also make sure that we spin down this timer in the background, just in case it were to get away from us anyhow, or potentially slow down the application shutdown. So now, while the cancellation token is not requested, we will await cancellation, or not cancellation, check timer, wait for next tick async, and then if our auth expert, let's see, death time UTC from our time currently, time, date, time, UTC now, and we'll say if the total minutes is less than or equal to 30, then, well, we can actually say if it's greater than 30, we'll continue. And then we will try to do a validate token. So we'll otherwise say await, validate token, and that should be good. And now we'll run this when the application first starts up. So when start async goes through and we validated our token the first time, we will then say task run auth check. And we'll just leave that running in the background. Now, it's going to throw a little warning at us because we're not awaiting this. I don't know if there's a more graceful way to do this presently. So we're just going to ignore this warning as we're ignoring multiple other ones. This is perfectly fine. So now we have a system where we're pulling our authentication information from a JSON file. We're validating it when the application boots up. We're also starting a timed event where every 30 minutes we will check and see if our authentication token is still valid. One other thing we can change in here is if we do happen to get past all of this, we can say if auth result, well, let's see, where would we do this? We'd want to do this inside of here. So if auth result expires in is less than or equal to 0, or auth, well, we can just say if auth result expires in is less than or equal to time span from minutes 30 total seconds. Because I'm too lazy to do basic math, and we can just rely on the time spans to calculate this for us. So then we're saying if our auth result expires in less than 30 minutes in seconds, then we will go ahead and refresh the token now. And that should help us make sure that we're not waiting until the token has already expired to refresh it. We'll create a new class file, and we'll call this one EventSub container. So the EventSub container is going to need a couple of components. We're going to need a reference to our API. So we'll use private Twitch API, and we can just keep using Twitch's API because since we're going through the dependency injection container, we don't need to do any setup. It should already be ready to go. And we'll have API, and then we need private iLogger EventSub container. And I think that's it. I'm pretty sure that's all we need. So we can take both of these and generate a constructor for them again. And then we can start building our functionality for the EventSub container right after we make sure that we do the same exact thing. So we're going to add it as a singleton and a hosted service as well. And then we're also going to add it as that hosted service. And then we will change things over there to make sure that it is deriving from my hosted service. Give it the same implementations. And then in here, we can do the same exact process where whatever we're trying to have run first thing, the moment that the application launches, it is done inside of this. And what is really, really helpful about start and stop async, particularly for EventSub, is that we can make sure that we gracefully disconnect from all of our EventSub subscriptions, because otherwise the Twitch API won't know immediately. And I don't know if TwitchLib automatically does this, but perhaps they already do, and it will spin down the EventSub connections. But either way, we can double check and make sure that we call it on our own. So what we can do now is also add our EventSub. So private EventSub WebSocket client. And this will also be a private thing that we pass through in the constructor. And on start async, the first thing we can do is say WebSocket connect async. Make sure this is async. And then what we want to do is we want to handle the event of connection and then do our listenings after that. So the first step is just getting the WebSocket connected, and we can store its session ID. And then we can use that session ID for things if we need to. So what we will do is inside of here, we will say socket session ID equals WebSocket session ID. And the only reason I'm pulling this out of here is just in case we want to compare it after disconnection events. And then we can say WebSocket up in the constructor connected, and we'll generate a method and we'll say on WebSocket connect. And then inside of this connection method is where we're going to handle all of our event registrations, and all of our actual listening should happen in here. So let's say we were going to listen to message received or channel message, channel chat message. So we'll just say that we're going to receive messages first on chat message. So the first step would naturally be saying logger, log information, chat message received from username, content. And then we can do message or metadata. And then let's see, it's payload, event, message. And then we can use that for message text for the actual text. And then it's going to be payload, event, username, chatter username. And then for now we can do return task completed task. So that's all well and good. That would allow us to technically respond to a chat message if we can actually read it. But the WebSocket doesn't by default listen to every single event. We can just say our listen result equals API Helix event sub create event sub subscription async, and you can see it's got a ton of parameters to it, but thankfully we only need the first few of them. So to leverage channel chat messages, all we have to do is listen for this specific subscription type, and we need to provide conditions for the method to actually be successfully called. It requires the broadcaster user ID and a user ID. If the broadcaster is the same account as the user, we still need both of these. These are just absolutely required conditions as far as it goes. So if you are just hosting your own bot on your own account, listening to your own account's event sub, just make sure both of these have the same ID. And otherwise, this one will be the ID of your broadcast, your broadcast account, and this one will be the ID of your bot. We're going to take another step here to acquire our user ID. And we're going to do that before we actually call for the WebSocket connection. So we're going to have a private string broadcaster ID. And we are going to use the API to call that. So we're going to do API Helix users get users async. And what happens if we do not include any IDs is we will get our information. So our broadcaster info. So in this case, since we're not passing it either an ID or a login, it's actually going to return the information looked up by the bearer token, which is in this case, our account. So if you're doing this for your bot, you are going to still need to get your IDs. So just make sure that you get those in here. But in my case, I'm just using my own account. So I'm going to just use the broadcaster info, and we can take in broadcaster ID equals broadcaster info data. Let's see, it'll be users 0 ID. And then that will get it my broadcaster ID. And then that will allow us to over here say channel chat message, the version type of 1, and then we just need to plug in our conditions. So to work with this system, we have a couple of options. I'm going to pre-cache my values because I just find that to work a little bit easier. So we're going to have a private dictionary of strings. And we're going to call this one broadcast and user ID because we need both the broadcaster and the user ID inside of this. And we'll just tell it that it's new for now. And then on our start async, where we're already recording our broadcaster ID, we're also going to say broadcast and user ID. And then we're going to set this up to use the same exact values as inside of the API reference. So again, inside of the API reference, you can see we specifically need the broadcaster user ID and the user ID here. So again, inside of Visual Studio, I'm just going to go ahead and throw these over here for now, just to make sure that we've got the exact names and all that stuff that are pulled from the documentation there. And then inside of this, we're going to make sure that our entries precisely match. So broadcast and user ID, and then it's going to be broadcaster user ID, and both of these will equal the same thing. So we just have to do this twice. So this will equal broadcaster ID. And then we do the same exact thing, except this one will be just user ID. And again, just to note, if you are using a separate account, make sure that one of these is your actual broadcaster ID and the other one is the user ID of the bot that is being able to listen to the event sub of the channel. And it only is the same thing in my case because I'm just using one account for both of these. So it'll be a little challenge to you to make sure that you implement this correctly for yourself. And then we can go back to our EventSub subscription async, and we can actually pass this dictionary through to it as a parameter. The last thing that we have to do is add the transport method. EventSub transport method of Websocket is what we want to use, not webhook or conduit. We want to use specifically Websocket for this. And then that should be all that we require. And then we just make sure that we await this, because with async, everything has to be awaited. And real quickly here, we'll just correct a couple of small mistakes that I've made in the execution of this. So we want to make sure that all of our information lookup occurs before we actually call connect asynchronously. So we'll make sure to put all those there. We don't need to worry about capturing the socket session ID here. We actually want to capture it when we first connect. And then finally, the last small mistake that I made there is that we need to pass the session ID. Why don't I put on word wrap for this? So we also want to pass through our session ID in the request. Because without this session ID, the API has no idea what WebSocket session we're actually requesting to listen to. And then between these things and setting this to return task completed task, we should be able to spin this up and hopefully it will connect properly. Let's see if it's working fully. So if I type the message test, we can see, yeah, it actually works. Chat message received from Settlix. And now that we've gotten ourselves to the point where we're listening to messages successfully, why don't we try to parse a command first? That seems like the natural next step. So unfortunately, WebSocket does not have a channel chat command. There's no chat command. So for the absolute sake of simplicity, it is just going to be a string check where we say if payload event message text starts with, and if it starts with an exclamation point, then it's a command. So we can just say if it doesn't start with one, we return task completed task for now, because we're not running anything asynchronous on this quite yet. And in the case that it is a command, we could just do a switch. And we'll say var first word equals, we'll say var split up equals payload event message text split by spaces. And then we'll grab split up 0 as the first word. We will say after the first index, because we don't want the exclamation point, and then we can do a switch on the first word. So then we'll just say case test command and break. So that way we ignore everything else, and if it is our test command, then we'll let it go through. And this is where we'll do our other test of the API to make sure that all of our scopes are working correctly. So we're going to say API Helix, and I believe it is send chat message. And then we should just be able to do a request for the message. So we can do new, and the broadcaster ID is going to be our broadcaster ID. The message is going to be, this is a response to the test command. So now when I actually go to run this function, we'll launch the console application again. We'll let it hook up and we'll do our !test command. And let's see, what did we get? Sender ID must be set. Oh, right, we actually have to set our sender ID as well. So in this case, sender ID equals broadcaster ID. So then we try and run it again, test command, and voila, this is a response to the test command. And just like that, we are now able to send messages in response to things and parse potential messages for commands and all of that. So something that very much needs coverage in the course of all of this is disconnection protection. So the WebSocket client is going to shut itself down every once in a while as Twitch doesn't want you connected if you're not actively using your WebSocket connection, so they will automatically time you out. I think it's somewhere in the range of like 24 hours. I don't know what the exact exhaustion time of the connection is, but either way, we need to detect when we disconnect. So when WebSocket disconnects on disconnection, we need to be prepared for this and handle it accordingly. So we're going to make a small change to the way that we handle connection in the first place. We're going to add a private bool. Should reconnect is what we'll call it, and we'll set this to true. And then on disconnection, we'll say if should reconnect is false, then we return and we do nothing. And otherwise, we'll try to process this as a reconnection. And this will end up being async, to my knowledge. Actually, it may not be, so we'll leave it task completed for now. And then all we're going to do is say, hey, WebSocket, do you want to reconnect really quickly? So then we will just say WebSocket reconnect async. And that's it. That's all she wrote. That's all we have to do, is just tell it to reconnect asynchronously, and we should be totally good after that. Everything should reconnect just fine, and we should be able to resume our session with no problems. And we can also then say on connection, if reconnected, return. We don't want to run the same logic that we run on our first connection for our reconnection. So all we'll do is return out if we are reconnecting. And then there we go. That'll help you manage reconnection protocols in the case that you do actually run this EventSub WebSocket for hours and hours at a time. Like I have a 24/7 listener that reconnects itself automatically, and you may end up needing something like that. So either way, that is the basics of the EventSub container and listening for events through it and making sure that we reconnect. So it's time for the other part of what I wanted to cover today, and that is redemptions. So redeems will be pretty much the same to process as a command. We can actually throw in the method for it right now. Redemption. So it will be custom reward redemption add, because we're going to be creating a custom reward for this. Custom reward redeemed. You can also detect the automatically deployed redeems. Those are the ones that are always there unless you switch them on or off and can't delete them and all that stuff. So for the sake of this, we'll just say logger, log information, custom reward redeemed. And we'll take bar redeem equals e payload event, just so we can save ourselves a little tiny bit of typing there. Redeemed name, and then we'll say E or redeem title or reward title. There we go. And then that would allow us to detect the reward. And then we can do the same exact thing that we're doing with the other one. We just have a switch, redeem, reward, title. And then for the sake of this, we'll just say my case, my test reward, break. And we'll do the same exact thing where we're just sending another message. So we'll take this same function, and if anything, we'll break this out into a method, because we might as well. We might as well do these kinds of things. And also, I think we were supposed to await that. So it's funny that it worked. It technically would have required an await. Send message, and then we'll have this is a response to the test command string here. And we'll replace this with message. And this needs to be async task. I'm not quite sure how it managed to work without awaiting that time, but we won't risk doing it again. So we'll set this up. Set this up as async task. And now our code is a teeny tiny bit more reusable. So then over in our myTestRewardRedeem, we can say send message. Hey, I just got that test reward you asked for. Thanks. And theoretically, at this point, we could also go into the API and mark that reward as completed. But for now, we'll just stick to detecting that the redeem has gone through. So next, we'll go ahead and actually implement creating a custom reward automatically through the application and shutting it down, as well as destroying that redeem when the application shuts down. So we're doing a simplified version where the redeem only exists while the application is running, and the rest of the time the redeem will not exist. So we're going to go ahead and create another class. We'll do that really quickly. And this one we will call the reward subservice. And we'll follow the same procedure as before, where we'll just have our iLogger. And we will need our API. And then both of these will get added to a constructor. And then once we've got that, all we need to do is hook it up for the hosted service. And then on start async, we're going to go ahead and create redeems. And on stop async, we're going to remove the redeems. And that's how we'll process this. So we'll create redeem, and we will remove redeem. So in this case, what we're going to do is we're going to go API rewards, or let's see, Helix rewards. What is it? Channels, channel points, create custom rewards async. And then we're going to need our broadcaster ID and all that stuff. So it probably would behoove me to have my broadcaster ID stored in a common location. I'm going to go ahead and just pull the same exact logic that I used to acquire my ID in the other class and do it over here as well. So if you don't like that method, I don't either, but it's going to work for now, and that's all that we really need. Private string broadcaster ID. And then we can create a custom reward in our channel. Broadcaster ID, and then we have our request for the creating of a custom reward. So we can just create new, and then we can fill this out. In this case, I'm not going to do much. We're just going to set the cost to be 10. We're going to add a title, test reward. We'll add a description. I think it has prompt. Yeah, prompt shown to the viewer when they redeem the request. So we'll also add that, and this will be, this is a test reward. How neat. And we don't need to worry about cooldown or input required or anything like that. I think a lot of these default to values. Yeah, so this defaults to false. Max per stream defaults to, it looks like it doesn't even apply it unless the other value is set to true. So we should be totally good just doing these here. So then that will allow us to create the custom reward. We're going to need to store that custom ID. So we'll just have private, let's see, what does it actually return here? Returns a create custom reward response. So let's get the response first and await this and make sure this is set to async task. And then inside of this, we can check our response and see if it's actually got what we're looking for here. So we'll say if response data length equals 0, and we'll just throw a new exception at this point. Failed to create a redeem, got no information returned. And then otherwise, we can actually process this as the redeem will exist. So we can store its information and leverage that. So we will keep our string redeem ID. in a private string there. And then we'll say redeem ID equals response data 0 ID. And then we have control over that redeem because we've created it with this client. So you cannot use your current client to modify redeems that already exist. You can only modify redeems that exist through the direct creation and destruction process of your individual client. Even if you have two separate instances that are using the same account, if they are coming from two different client IDs, like you have one on application A and one on application B, they will not be able to share control over those redeems. It is purely based off of each individual instance. So if you want to have all of your redeems stored in one place and controlled in one place, you're going to have to build them all through the API systems. You cannot use the manual menu creation of them. It won't allow you control over those because they're created technically with a different user token. They're created with the user token that you have on your dashboard on Twitch rather than through the API like we're doing here. So assuming that we've created it, we also want to destroy it when the application shuts back down afterwards. So we will say await API helix channel points. And I believe is it delete? Yeah, delete custom reward async, and it should just be our broadcaster ID and the redeem ID. And that's it. That should make sure it's destroyed afterwards. So then we'll go ahead and go to program and make sure that this is registered as a singleton in the hosted service. I'm going to borrow these to save myself a little bit of time here. Reward subservice will get registered there. And then we'll just do a quick double check. So we're starting async, we're getting our user information. We're then trying to create a reward under the name of test reward that costs 10 channel points and is a test reward, and it's very neat. And then as long as everything succeeds, we don't throw an exception and we record our redeem ID. Then on stop async, we'll go ahead and destroy that redemption afterwards. And before we can use it, there's one last step in this process that I overlooked here. Well, a couple of small last steps that I've overlooked in this process. So first we need to say is enabled equals true so that the redeem actually can be active when we first add it. Otherwise, it'll be hidden and you'll have to do a second API request to enable it. And secondly, over here, I've named it my test reward, and over here, I've named it test reward. Something that can be helpful is having like a public static lookup listing class somewhere for these things. For the sake of this tutorial, I'm just going to name this my test reward to make sure that everything is correctly synced between the two. So we're listening for my test reward in our switch statement that we're making on any redeem being received. And we're also going ahead and making sure that we have enabled this redeem. So now if I go ahead and hit play and we take a peek at my chat, we can see that I have added a new reward, and it's randomly picked a color. I think it just always randomly picks colors unless you designate them. And we should be able to hit redeem and we get our test reward, but it looks like we're not seeing it. And that is because we haven't actually listened for redeems yet. But we can still show that when the application closes, the redeem goes away. So that whole process is functioning correctly. And all we've got to do now is make sure that when we are booting up EventSub, we also give a listen for redeems. So we're going to do basically the same exact process for listening for chat messages. The parameters may be a tiny bit different, so we'll have to double check this. But either way, it should be as simple as just running the same exact kind of command here. It's just instead of channel chat message, we're going to be looking for a redeem. So we'll make this redeem result, and we will find the entries that are required for this. And as we can see here in channel points custom reward redemption add, we need the read redemptions and manage redemptions scopes, which I believe we've already added. And it is a very massive subscription type name. So we'll take this entire subscription type name and we will utilize this over here. So instead of channel chat message, it's going to be channel points custom reward redemption add, and then it requires the broadcaster user ID. Just the broadcaster user ID. As you can see here, we also have the opportunity to add a specific reward that we listen to, But in this case, we want to listen to every single reward on the entire channel. And instead of a broadcast and user ID, we just need the broadcast ID. So we'll make another one of these that's called broadcast ID only. And when we're declaring this one here, down here, we will also take this, and it is broadcaster user ID that we're adding. So then it will be broadcast ID only. And we'll have that one set and set it over here. Broadcast ID only. And now, when we launch the application, it should listen to rewards as well as chat messages. And as a result of that, when we redeem our test reward, it sends a message in the chat. You now have the power to create and destroy redemptions with the API. You can manage your auth token with the API. You can listen to any EventSub stuff that you want on your channel and potentially on others as well, as long as you get their consent and operate within the terms of the Twitch developer agreement. You've got full reign of doing whatever you want now, so you can have at it. So thank you very, very much for joining me in this little journey here. Thank you very much for tuning in. If you enjoyed this tutorial, please do consider swinging by my Twitch stream. I stream a decent few days a week, and you can find my stream over at twitch.tv/Settlix. But either way, thanks for hanging out. Thank you for joining me in this learning journey. Very much hope you learned something, and bye-bye.